Okay, so this would be an example of a video I would create after teaching a lesson, especially a new topic. I like to go over any of the new vocabulary, any of the concepts, kind of walk them through the notes one more time, and maybe do a couple example problems with them. Probably wouldn't go as far as doing problems of the day. I would in this case just because it's kind of all on the same paper, and that way you're using the problems of the day in this problem to kind of later on in the lesson the concept you're learning in this. But I find doing this is extremely beneficial, and I think any math teacher would, if they want to take the time to do it. If you have kids that are absent, this is a great thing to show them. That way they can watch it at home. If they know they're going on vacation, you have them up. If you're planned out that far ahead, you'd have them up so they can check that too. If they're just stuck at home, stuck on homework, whatever, it's just one more tool they would have at their disposal, and they can go and check at any time. My students find it extremely useful. A lot of them have come to me and said that they wish other teachers would do this. Had a lot of success with this, so I'm hoping that you'll see the benefits of doing this. But anyway, let's get started. So what I would do is the first problem says convert the mixed number to an improper fraction. So remember, guys, in order to do that, multiply the denominator by the whole number part and then add it to the numerator. So 11 times 4 is 44 plus 5 is 49, and the denominator remains the same as 11. We're going to use that skill later on when we deal with complex fractions in this lesson. We have a complex fraction as our second problem of the day. Now, a complex fraction basically is just a fraction over a fraction. In this case, what I find extremely helpful to do first is identify the middle bar of the complex fraction, because that separates the numerator from the denominator, what's acting as the numerator and the denominator here. So it's actually dead center in this one. So we're going to put parentheses around that, so that way I know this is the entire numerator, this 49 over 11. And then I'm going to divide it by, because that's what the big fraction bar in the middle means, 14 over 11. Now, rule of thumb when you're doing this, guys, whenever you're dealing with a mixed number like we had up here, convert it to an improper fraction, especially when you're dealing with a complex fraction. They're a lot easier to work with. And now it's something that we've all seen a million times. It's a lot easier to work with. The division symbol becomes a multiplication. This will become its reciprocal. And then just chug the problem that way. 11 across from 11, that's going to simplify out to be 1. 49 and 14 have a common factor of 7, so that's going to reduce to 7 over 2. If you want to take it a step further, make it back a mixed number, just divide it out, you'd get 3.5. So either one of these answers would work. If it were a test and quiz, you just follow the directions. If I didn't specify, I would take it 7 over 2 as an answer. If I said make all improper fractions mixed numbers, or vice versa, or whatever, that's how you would know to keep going. But let's start with the new material. So the unit rate. A unit rate compares quantity to 1. Unit rates can be determined from proportional graphs, tables, equations, and verbal descriptions. And that's the study island definition. In other words, it just means we're going to start attaching units to our division problems. But we have to do it in a very specific way, because math is very specific with lots of things I'm sure you're aware of now, and this is no exception. So let's start with some common phrases that mean rate. Now, the one shows up a lot in word problems is in each. Another one you might see would be just something simple, a little bit different. For each, and sometimes they come right out and they'll say in one. Now that may not seem like a lot of sense right there in that context, but if you look at some of the examples I've included in here, you can kind of see what I'm talking about. We have liters of water in each balloon, treats for each dog, or the amount of text sent in 1 hour. So I made them all in bold so you can see that's the part that would be separating your numerator from your denominator. And when we get a little further into this, I'll show you what I'm talking about. Basically, it's any word or phrase that implies the word per. You're going to find the word per in algebra, especially in algebra, implies a rate or a rate of change in algebra. We commonly call them slopes. That's what they're gearing you up for here. They're gearing you up to start graphing lines. It's nothing to get scared about. We're not going to do it right here. It's really easy, but if you can wrap your head around how a rate and a unit rate is created, it's going to make algebra a lot easier for you down the road. So you come up with your own example, and as far as I'm concerned, if it has the word per in it, it's a valid example. So if you want to say pizzas, that's a weird looking pizzas per party. Okay, you know, if you've got 20 pizzas and you've got 5 parties, how many pizzas for each party? That's what a unit rate is. Let's take a look at some context problems. So sometimes they're going to throw graphs at you. And just as a quick review, you should always label your graph if it's not labeled. But the y is always the one going up and down, and x goes horizontally. So the way I always have kids remember it is that your y points to the sky, and if pirates always bury their treasure in the ground, so x marks the spot. So the x is always going parallel with the ground. So rates are always y per x. So mathematicians agreed long before you and I were even around that the y-axis is always going to be your numerator and the x-axis is always going to be the denominator. So your fractions are always following that format. So whatever the units of your y-axis is, that's going to be your numerator, and whatever it is on the x is going to be the denominator. So for example, maybe this y-axis were squirrels. If this were squirrels and say this were parks, you would say squirrels per park. Or maybe it would be students per classroom, or whatever. As long as it's separated by the word per separates your y from your x. And in Algebra 1, you're going to see how important that concept really is. So anyway, let's take a look at an example and I'll show you what I'm talking about. Stephanie is painting her bedroom. She can paint 2 1/3 square feet in 1/5 of an hour. How many square feet can she paint in 1 hour? So first, identify the unit rate part, because you don't always know what the numerator is and what the denominator is until you get to that part. It's not always going to be always take that number and divide it by the second number. That's not what I'm saying. I'm saying look at the unit rate. The unit rate in this one is square feet in 1 hour. So in 1 was one of our phrases. That means the word per. So we have per there. So that's telling you that square feet is the numerator and hour is the denominator. So we have 12 and 1/3 over 1/5. Now we have a complex fraction. And those complex fractions can be kind of scary, but just remember, first let's convert any of the mixed numbers into improper fractions, just like we did with our problems of the day. 3 times 12 is 36, plus 1 is 37. Over 3 divided by 1/5. Looks very similar to our problem of the day example, so rewind the video if you want to look at it. So we have 37 over 3 divided by 1/5, and remember that means that 37 over 3 times 5 over 1, and then we would multiply straight across. 37 times 5, if you're working it by hand, you know, I always like to show my work. This is how I was always taught, and I think it's a good habit to get into. I have 185, 3 times 1 is 3. And then I'm just going to reduce my fraction because that looks awkward. Like no one's going to say I can paint 185 over 3 square feet every hour. It doesn't really make sense. So it's better to convert it back to a mixed number. So 185 divided by 3 would be 6, 1 with a remainder of 2/3. That's a little something more we can see, 61 and 2/3. But 61 and 2/3 what? It all comes back to our units. 61 and 2/3 square feet per hour, and it's a little cram there, but you get the idea. That would be your answer. And that's the big push with all the open-ended questions with PSSAs and Keystone tests and ACTs and ACTs. And even if you don't take those tests, if you're working for someone someday, you have to know what the number is trying to tell you. And you have to be able to relay that information to somebody else. So we know that this lady can paint 61 and 2/3 square feet of her bedroom every hour. So, and then whatever we did with that value, we would take it from there. Let's take a look at Adam and see what he's got going on. Adam bought a new video game. He graphed the points that he's earned below. What is the rate of points per minute? So without even looking at this graph, I know that points is his y-axis and minute should be his x-axis. And they are. So his graph is set up correctly. So it's points per minute. So we got to look at this. Now what you want to do for this problem, let me zoom in just a smidge so you can see. You're looking for a point that lines up perfectly on the line and the grid. So a grid point, that's what I like to call them. So one of the grid points would be right here at the quartered pair of 2, 5. Now if you say 2, 5, you'd be wrong, because look, right here in the fine print, and you'll see in real life, it's always about the fine print. That's what always gets you. Is this one's in thousands, so the ordered pair of 2, 5,000 is what you're really looking at. Now, there's usually other points, and there's not always points that line up on grid points. Sometimes you just have to deal with it, and that would be a topic for another day. But for this, we would take his points. over his time. So we have 5,000 points over 2 minutes, which would reduce to 2,500 points per minute. And like I said, they want us. We're going to put that in the little spot down here so it's easier to read. So 2,500 points per minute. So hopefully that helps. And I think you would see. Boy, I need to zoom out. Holy smokes, I do that all the time. So let me just back up the truck here and we'll take another look at it. So I got my grid point. My grid point was 5,000 over 2. 5,000 over 2 reduces to 2,500. 2,500 points per minute. And I just wrote it in the block, in the space provided below. But that's it. That's what I normally do. That's a typical lesson from Luke Frey. So hopefully you enjoyed it. Thank you.